So today we will start the last lesson, lesson 4, in topic 2, and it's about parallel and perpendicular lines. It's kind of an interesting lesson today. I think it'll be a little fun. And we get to use another website today too. Your notes are going to start on page 45, so if you will turn to that in your book, that'll be helpful. And of course, your homework or assignment or practice or whatever you call it is posted in Schoology. So here we go. The first thing your book says is graph these three equations using a graphing calculator. And you might be saying to yourself, I don't have a graphing calculator. Well, don't worry, we've got you covered. We're going to be using the Desmos calculator today, which is really helpful too, because that is something that you can also use on many standardized tests. You will be allowed to use it for your EOC, so it's good that we get used to it. And we're going to be graphing these three equations, so you're going to be referring to that when we go to desmos.com. Now, one way you can do it, for me, I can just click on this. So if you are watching at home, you can hopefully just click on it too and take it right to it. You can also just type in desmos.com on another tab, and that will also take you to it. So there's many ways that you can go to it. If you go this way and you go in here, you're going to want to click on the graphing calculator. Make sure you're on the graphing calculator. So let's go there right now. So this is the Desmos graphing calculator, and you can use your keyboard to put equations in. You can also use right down here. Hopefully you can see this. I'm going to click on it right now, and that bottom left-hand corner, it gives you a keyboard. And the first one we're going to type in is y equals 3x, just ignore that, plus 1. I could also, on my computer, I could write it in, but it's really kind of catchy. So my first line is in red. My first line is going to be in red, and that's going to be helpful. Now click on that next line, and you're going to type in your next equation. Y equals 3x plus 2. Now notice that one comes out to be blue. So when I'm on the blue line, right here I'm on the blue line, that's my second equation. Now my third equation, I don't want that. So I'm going to go back and I'm going to hit my next line. Y equals 3x plus 4. And that one turns out to be green. Okay, so my red line, right here, that's going to be, and I can show you my red line. If I want my blue line, I've got this line right here, and of course my green line. So look at all those. Now go back to your book. What do you notice? What do you notice about these three lines? So it says choose any two of your lines to think about. You graphed, how are they related to each other? Okay, so let's say that you chose x plus 1 and x plus 2, your blue and your green line. Now again, your line colors might be different than mine, don't worry about that, but you had 3 different colors. Okay, what do you notice about them? That's right, these are parallel lines. Okay, so does your answer to part A hold for any of the two lines that you see? So let's say that I took the first line and the last line. Are they still parallel? Yes, they are. Okay? Now, I want you to look at those parallel. Sorry, I misspelled that. Okay, they're all parallel. So we notice that they're all parallel lines. Now look at my equations. I kind of wrote all over them. What do you notice? Oh my gosh, my board is freaking out. What do I notice about all 3 of those lines? Do you see it? Do you see what's happening? Look right here. Right? Your slopes. So go to C in your book. And it says write a set of 3 or more equations that have the same relation as the first 3. So write down 3 equations right now. Then go out to Desmos and see if those 3 equations, what happens with those 3 equations. Referring to this first set, so what do I notice with all the 3 equations? They all start off by saying 3x. Okay, so try up minus 1. Y equals 3x plus 5. Y equals 3x minus 4. Graph those. Right now, we're going to go out to Desmos and do that. Y equals 3x x minus 1. Oh, my other lines disappeared, didn't they? Okay. Y equals 3x plus 5. Y equals 3x minus 4. Okay? So hopefully your lines will still there. But what do you notice about these? Yes, exactly. And what did I notice about these? My slopes. My slopes are all the same. My slopes are all the same. Now, if you look at your y-intercepts, they can be whatever they darn well please. It's the slopes that matter. So our summary is parallel lines have have the same slope. Do their y-intercepts matter? Nope. They can be anything. Their y-intercepts do not matter. It's just the slope. The slope. Okay? What concepts have you learned previously that were useful in analyzing this? Well, we had to be able to identify the slope. Okay? We had to know what parallel lines meant. What do parallel lines mean? Okay, so we had to use that. And we had to know about graphing. So we used some of those same concepts. Good. So now we're going to use this information to be able to write an equation of a line in slope-intercept form that passes through this point and is parallel to this one. Okay, what does it mean if lines are parallel? Right, the slope is the same. So here is my slope. What is going to be the slope of my new line? Exactly, negative 2/3. That is my slope. Now we're going to use this point. Now we have two ways we can approach it. We have to end up in slope-intercept form. We can start off by using slope-intercept form, or we can start off by using point slope. Both of them are good. Y minus y sub 1 is equal to slope times x minus x sub 1. I am actually a fan of using point slope. For my brain, it's much easier, but I'm going to show you how to do it both ways because I want your brain to decide what is easier for you. So I'm going to start with my favorite because I'm the one with the pen, so I get to do that. So I'm going to plug in my point, and I'm going to plug in my slope to point slope form. So y minus my y value, so 5, is equal to negative 2/3 times x minus my x value. Okay, now I can cross the line and change the sign here, and you know me, I'm going to because I'm bad with negatives. And then I'm just going to clean up my equation. Y minus 5 is equal to negative 2/3 x plus negative. If I take 2/3 times 3, see how my 3's drop? So I have a 2, or they divide out to 1. Now, if I want to get it in slope-intercept form, I still need my answer in this. All I have to do is get y by itself. So I'm just going to add 5 to both sides. So I get y is equal to negative 2/3 x minus 3. Whoops, that's not right. How about a plus 3? Because I have a positive 5 and a negative 2. How about plus 3? So there is my answer, using point slope. That's using point slope. Now I'm going to go and I'm going to use slope-intercept. So, and in place of y and x, I'm going to put negative 3 and 5. So 5 is equal to my slope. Whoops, how about if I write the correct slope? Would that be helpful? So negative 2/3 times x, my x value right up here, plus b. So I'm solving for b. So I get 5 is equal, my 3's drop, divide to 1. So I get a positive 2 plus b. Now I'm going to subtract 2 from both sides, and I get y is equal, I get 3 is equal to b. So there's my y-intercept. So my final equation, y is equal to my slope, negative 2/3 times x plus my y-intercept, 3. Ta-da! I got the same equation either way. So today I want you to practice, which way do you like better? Do I want to put it in slope-intercept? Do I want to put it in point slope? Both of them are good. So you decide. Okay, good. Let's try another one. So this is on page 48 of your book. Page 48, go to page 48, and you're going to find this problem number 5. The equation y equals negative 3/4 x plus 1 represents a given line. Write the equation that passes through this point and is parallel to the line. Okay, so you can either do it in slope-intercept or in point-slope. Okay, I would like you to try one of them right now. I'd like you to pause and try plugging it in to one of them using this point and this slope, and plug it in and find the equation. Remember, your final answer has to be in slope-intercept form. Okay, it does not say that here, but it should. Your final answer should be in slope-intercept form. Okay, remember this is slope-intercept right over here. That's what your answer has to be at the end. That doesn't mean that you have to start with it. Okay, so hopefully you're trying it. So I'm going to put it in my favorite, which is point-slope, so I'm going to do that one first. If you use slope-intercept, ignore me right now and just fast forward through this part and watch how I did it for slope-intercept. So y minus my y value is equal to my slope, negative 3/4 times x minus negative 4. Of course, I'm going to cross the line and change the sign. Now I'm just going to clean it up. What I have there, y minus 9 is equal to negative 3/4 x plus, they won't always be this way, that they always cancel out, but that's okay, negative 3. I'm now going to get y by itself, so I'm going to add 9 to both sides. Y is equal to negative 3/4 x plus 6. And I'm done. There's my answer. If I'm doing slope-intercept, I'm going to plug in 9 for y. So I plug in 9 is equal to my slope, negative 3/4, times my x value of negative 4 plus b. So I get 9 is equal to negative 3, because, of course, my y's cancel out, and that would be a positive 3. Thank you. And then I'm going to subtract 3, and I get 6 is equal to b. So my final answer is y is equal to negative 3/4 x plus 6. It does not matter which way I do it, I'm going to still get that same answer. Okay? And this is a disadvantage of videos, is if I were in class with you right now, if we were in class together, I would have you say, do you want another one? And then I'd give you another one. So let's just move on for now. Hopefully you're getting that. So now we're going to go out to Desmos again. So write down these equations, if you will, for me. Write down these equations in the side column or whatever. Write down A. Just write down A for now. Y equals 2x minus 5. And y equals negative 1/2 x plus 4. Write that down for me. We're going to go to Desmos. Here we go. Okay, so out here, we're going to graph two equations. We're going to graph y equals 2x minus 5. Let that line just hang out. That's our purple one. Now we're going to also graph y equals, now it's negative 1/2, so I'm going to have a negative 1 divided by 2, and see, it goes right into a fraction. So I have my fraction, and then I'm going to come up here to the side. Did you notice I had to click up to the side, and it's x plus 4. Okay, now what I want you to do, if you can, is look at those two lines. And yes, you probably already noticed I talked about perpendicular lines. Okay, and what do you notice about these? They are perpendicular. The other thing I want you to notice is I want you to pick 2 points. So let's find a whole number point. Here's a whole number point. Okay, see that whole number point right there? And let's find another whole number point right there. Nope, it says it's not. Let's find another whole number point. Is that a whole number point? Nope. Let's find a whole number point. Aha, nope. So what I'd like you to do is I'd love for you to count and figure out what that slope is. One of the disadvantages, okay? What you would find out is that the slope of these two lines, okay, you can actually see. Let's go back to my screen for a second. Now when we saw those perpendicular lines in Desmos, look at your slope. Look at your slope. Okay? What do you notice? Great. Let's go and graph these other two. So write down these two equations. Y equals negative 3/4 x plus 1. Y equals 4/3 x plus 2. Write those down. So now we're going to write down our equation y equals negative, so minus 3 divided by 4. Move your cursor off to the side. X plus 1. There's a nice little red line. And now we're going to have y equals 4/3, so 4 divided by 3, x. And look what happens. I don't even have to put in the rest of it. What kind of lines do you see there? Now I could plus 2 or whatever. Doesn't really matter. Notice those lines. Okay? They form a 90-degree angle right there. And if we could count our slopes, my computer is not doing it. In class, I would have us count the slopes. You would see that your slopes come out to be, what are my slopes here? Okay, do you see that they're reciprocals? And do you see that one is negative and one is positive? Okay, we would call these opposite reciprocals, or sometimes we call them negative reciprocals. So, if I'm going to summarize perpendicular lines, you might have to write this off to the left or the right column in your book just to give some space, but this is important. Slopes of perpendicular lines are, some people will say opposite reciprocals, some people will say negative reciprocals, are opposite reciprocals. Opposite means opposite signs. Okay? Or you could say negative reciprocals. Either one. Negative reciprocals or opposite reciprocals. Opposite reciprocals probably is a little better. But anyway, summary of perpendicular lines, the slopes are going to be opposite reciprocals. So notice here, I had a positive 2. Here I had a negative 1/2. Good. Let's use that now. I like this question. Okay, so why does it make sense that the slopes of perpendicular lines have opposite signs? It's because they're going in opposite directions. Okay, if I have a line here and I have a line here, see how this one has a positive slope? Sorry, that one has a negative slope. This one has a positive slope. So that might help you too. See that they're going to go in opposite directions. Even if I have horizontal and vertical lines, okay, they're going to go in opposite directions. Vertical, horizontal. These are also perpendicular lines. Hey, while we're here for a second, look at this. What is the slope of a horizontal line? It's 0. And if I did the reciprocal of that, wouldn't I get an undefined number? Undefined, let's spell it right. So an undefined number. And as we've talked about before, my slope here would be 0 over a number. My slope here would be some number over 0. So they are reciprocals of each other. Good. Let's move on. Now we're going to talk about writing equations of perpendicular lines. So if I'm going to write the equation of a perpendicular line, okay, what do I notice? So think about your slopes. So here is my slope, right? If I want it to be perpendicular, what am I going to have to do to that slope? That's right, I'm going to have to flip it, but I'm also going to have to change the sign. So I'm going to have to flip it to be its reciprocal, and I'm going to have to change the sign to the opposite. I had a positive, now I'm going to have a negative. Then I'm going to use this point. We're going to do the same thing we've been doing. Either you can plug it into slope-intercept form to begin with. You can use that to get there. That's going to be our answer by the end. Or you can plug it into point-slope form. Y minus y sub 1 is equal to slope times x minus x sub 1. Okay? So, I would like you to try this one. Are you feeling brave enough? Can you try it? Pause it anyway. Pause yours. I'll come back in and do both of them. So if I plug it into point slope, it's going to be y minus 5 is equal to negative 1/2 times the quantity x minus 4. So I get y minus 5 is equal to negative 1/2 x. And then I have a negative times a negative, so it's going to be plus 1/2 times 4. I can divide out the 2, so I get a 2 there. I'm going to add 5 to both sides, so I get y is equal to negative 1/2 x plus 7. If I use slope-intercept, I'm going to have 5 is equal to negative 1/2, because I have to use my new slope, what makes it perpendicular, times 4 plus b. So 5 is equal to negative 2 plus 5. I'm going to add 2 to both sides. Sorry, plus b. So I get 7 is equal to b. So my final equation, using my new y-intercept and my new slope, I get negative 1/2 x plus 7. Notice my answer is the same whichever way I do it. So on page 48, you would have this equation, and it says, write the equation of a line that passes through 6, 6 and is perpendicular to the given line. So of course we're going to look at the slope. Sorry about that. We're going to look at the slope and know that we have to write its reciprocal, and it needs to be positive. Okay? So that's what we're going to be using. We're going to be plugging it into either slope-intercept form, y equals mx plus b, or point slope, y minus y sub 1 is equal to slope times x minus x sub 1. And I'd like you to try it on your own. Try whichever method you want, and then let's come back and compare. So if you did it by point slope, you would have plugged in a 6 and a 6, and you used your new slope of 4/3, the perpendicular slope. Then we would have found out that 4/3 times 6 is actually going to be 8, and we come up with our equation right here. Okay, so now if you did it that way, you can skip this next part. I'm going to show how to do the y-intercept, so I'm going to plug in 6 is equal to 4/3 times 6 plus b, so I get 6 is equal to 8 plus b, subtract 8, I get negative 2 is equal to b, so my final equation here is y equals 4/3 x minus 2. Shouldn't be surprising because we just saw it over there. Hopefully your brain is starting to figure out which one you like better. Now, this next thing we're going to do, these practice problems, is we have to determine if the equations are parallel, perpendicular, or neither. And of course, we're going to be looking at their slopes. If they're parallel, they're going to be the same slope, right? And if they're perpendicular, they're going to be opposite reciprocals. And if they're neither, guess what? They're not going to be the same, and they're not going to be opposite reciprocals, so they could just be anything they want. Now on A, they were really nice. They already have it in slope-intercept form. And slope-intercept form is the easiest way because you can identify slope right to begin with. Although point slope would be easy too, but we don't usually write it that way. So we look at these two. I have a slope of 2. I have a slope of 1/2. Are they the same? Nope, so they're not parallel. Are they perpendicular? Are they opposite reciprocals? Well, they are reciprocals, but they're not opposites. So this one is neither. Okay? Now, if we look at B, yay, we have the slope right here. But look at this one. We have to get this into slope-intercept in order to find out what it is. So to get it into slope-intercept, we have to rewrite the equation. And to get it in slope-intercept, all we have to do is get y all by itself. So the first thing we're going to do is we're going to subtract 25x. And we get 5y is equal to negative 25x plus 1. We're now going to divide through by 5. And we get y is equal to negative 5x plus 1/5. Okay, and the nice thing is all we care about is the slopes. So we don't even care what this is down here. So look at your slopes here. I have a slope of negative 5. I have a slope of negative 5. They are the same. So what kind of lines do I have? I have parallel lines. These are parallel. Okay, great. You get to try the next. So go to page 48 and go through what we were just talking about, if they are parallel, perpendicular, or neither. Go. So the first thing you have to do is you have to get these into slope-intercept form. So I have negative 3y is equal to negative x plus 6 divided by negative 3. And I get y is equal to 1/3 x minus 2. Here I'm going to subtract x, and I get negative 3y is equal to negative x plus 9. Divide through by a negative 3. And I get y is equal to 1/3 x minus 3. And all we care about are the slopes. Look at those slopes. Are they the same? Yes, they are. So what kind of lines do I have? I have parallel lines. Hopefully that's what you got too. Now in 8, they were nicer to you, weren't they? If you haven't already done it, do it right now. Look at those. Okay, so look at my slope. 4 and negative 4. Are they the same? Nope, so they're not parallel. Are they opposite reciprocals? Well, they're opposite, but they're not reciprocals. So these are neither. Okay, good. Now let's go back and look at these. I believe we're on page 47 again. We have an equation y equals 2x plus 7. And it says that represents the North Pole on the map. I don't know. That's the north path. The north path. That's what I was reading wrong. Find the equation of the path that passes through the point 6,3 and is parallel to the north path. Okay, so we're going to do that right now. Take your slope. Okay, find the one that is parallel. Go. Hopefully you tried that, and your slope is 2. Here's my point. Y minus y sub 1 is equal to slope times x minus x sub 1. So y minus my y value is equal to slope times x minus my x value. And we're just going to solve that. Not solve it, sorry. We're going to simplify it and get it in slope-intercept form. Y is equal to 2x minus 9. Okay? I will also do slope-intercept. So if you prefer slope-intercept, this is what your work should be looking like. You'd, of course, get the same equation. Now in this next one, we have to find it's passing through the point, but it is perpendicular. So the only difference is my slope. I'm going to do the same stuff. I'm going to come up with different y-intercepts, but I just have to pay attention to that slope. I have a slope of 2, so what is my slope going to be here? Write it down. And did you write down negative 1/2? Nice job. Okay, so plug it into the form of your choice, either slope-intercept or point slope. Go. So if you did it by point slope, you're going to be using this work over here if you did it by slope-intercept. So pause, check your work. No matter what, you come up with y is equal to negative 1/2 x plus 6. So this one's kind of out of order, but perpendicular and parallel lines. What's the advantage of using, explain the advantage of using slope-intercept form of an equation when determining if two lines are perpendicular or parallel? Well, slope-intercept, okay, it shows you slope right away. Shows slope. It's given. And so it's really easy to just look at the slope, and if it's parallel, it's the same. Perpendicular is going to be a negative reciprocal. We are now on page 48 in your book, just going through some questions there. I picked my favorites. Dwayne stated that the slope of the line is perpendicular to y equals negative 2x, so here's my equation. He is saying the slope is 2. What is Dwayne's error? Explain that. You've got it. You know what it is. That's right. The error is, the mistake is that the slope has to be an opposite reciprocal. And he only did the opposite part. Okay, so you probably wrote it better than I did on that one. In other words, what happened is he did not write the reciprocal, he only changed the signs. Number 3, describe the difference between the slopes of parallel lines and slopes of perpendicular. Well, if they're parallel, they're going to have the same slope. And if they're perpendicular, the slopes will be negative reciprocal. Opposite reciprocal. See, I even say it usually as negative reciprocals. Okay? I love this question because you have to think. Is there one line that passes through the point 3, 5? Okay, has to pass through that point that is parallel to the lines represented here. So it wants it to be parallel to both of those lines. Can I pass through a point that's parallel to both of those lines? The point, okay, that's a distractor. Look at right here. What you're paying attention to is the slope. Can I have a point, can I have a line that goes through this point that's parallel to both of these? Well, no, because these two don't have the same slope. These two, the two equations, are not parallel. Because they don't have the same slope. So there's no way you can find a line that's going to be parallel. Doesn't matter what the point is. These two aren't parallel. So you can't be parallel if two lines if they themselves are not parallel. And the last one we're going to look at on page 48 is number 9. What equation represents the road that passes through the point shown and is perpendicular to the road represented by the red line? So we're going to use the point of 1, 0, and it has to be perpendicular to this. We want it to be perpendicular. So the first thing is we have to find the slope of this line. So I'm going to pick two whole number points. I have a point right here, and I have a point right here. Now be very careful. Notice each line is 2. So I'm going to go up 2, 4, 6. So I went up 6, and I went over one line, so I went over 2, because each line is worth 2. So my slope is going to be 3. That is my slope. So use this as your slope, this is your point, go. So using point slope, you came up with y equals 3x minus 3. Using slope-intercept, you also came up with y equals 3x minus 3. So if you did not come up with it, pause yours, make sure you look over it. So that is the end of the notes. Hopefully that is very helpful, and hopefully you're prepared to go and do your homework now. Thank you very much. If you have questions, you know where to find us.